Software Architecture with Ted Neward.
The Azure and Devops podcast is a show for developers and DevOps professionals shipping software using the latest in .NET, Azure, AI, and DevOps. Listen on to learn how to increase quality, ship quickly, and operate well. The show is sponsored by ClearMeasure, a full-service software architecture and engineering firm. Find them at www.clearmeasure.com. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. I have a returning guest on the show, Ted Neward, and he currently labors on behalf of Capital One as a senior distinguished engineer, leveraging his speaking, his writing, his coding experience to bring a technology-focused and sharpened mindset to the mortgage industry. And during his more code-focused years, he specialized in high-scale enterprise systems, working with clients ranging in size from Fortune 500 corporations to small 10-person shops. And he's an authority in both Java and .NET technologies, particularly in the areas of systems integration, both in process and via integration tools like web services, etc. And he's spoken and taught and used all kinds of programming languages of all forms, back-end enterprise software systems, and virtual machine engine plumbing. He's done it all. And he's also the author of several books, including being co-authors. And the books include Professional F# 2.0, Effective Enterprise Java, C# in a Nutshell, SSCLI Essentials, Server-Based Java Programming, and he's also a contributor to several technology journals. And all told, he's written well over 100 articles in both print and online form, and they just keep coming. Ted has also been an insider, or of one form or another, with a variety of the technology providers of the world, IBM Champion of Cloud, a Microsoft MVP, and he's also been an F# Insider, C# Insider, VB Insider, iNeta Speaker, which is the International .NET Association, Develop Mentor Instructor, Pluralsight course author, and a member of various Java JSRs. He lives in the Pacific Northwest with his wife and 2 cats and 12 laptops, 7 tablets, 9 phones, and a rather large utility bill. So, Ted, welcome back to the show. How are you, sir?
I'm doing well. You remind me that I probably need to shorten up my bio a little bit. That was
in all fairness,
quite a weight of words.
You do a good job on your own website of having a short bio, a humorous bio, and a long bio. And I like to use the more complete introductions because you have done a lot. And I think it's important for the listeners to understand the level of expert that they're listening to. You're not just in the first 5 years of your career. You've done and seen a ton of stuff.
Yeah. All that gray in my beard, kids, that's all hard earned. I've been around the block a few times. I've done a few things, professionally since 1995, so 30 years, and unprofessionally since 1978 was when Dad first brought home the Apple II Plus with a whopping 48K of RAM. It's been an interesting ride being me over the last 50 years. So
nice. So there's a whole lot of people who have started off as programmers who end up just kind of moving into management and then taking their hands off the keyboard and whatnot. What keeps you motivated and just interested in the tech, or just keeps you motivated and locked in?
Well, I mean, there's so many answers are vying for control of my mouth right now. It's a multi-threaded concurrency problem. There's so many different interesting problems that go on in the tech space. And, one of the things that I've been talking about in keynotes and at conferences and whatnot is, for example, I believe our industry is deeply overdue for a new set of or singular mainstream programming language. right? And I don't mean Python is going to take over, even though that's kind of everybody's current, look, Python has, captured more programmers than. I mean a completely new way of looking at things,
Mm.
right? Because, both Java and C# are old enough to drink now. I mean, seriously, right?
Right.
They're both old enough to walk into a bar and have a beer.
Oh,
And
boy.
that presents an interesting problem for us because, object orientation is definitely a way of thinking about how we reason about software, but it's not the last, it's certainly not the only one. We saw an interesting injection of ideas when the functional languages came out. And for a long time, I really thought the natural synergy between function and service would really lead us towards the idea of these functional languages kind of
Mhm.
supplanting in the same way that Java and C# supplanted C and a bunch of the other procedural languages. Well,
Yeah.
they supplanted C++, who was the object version of C, the system. I mean, you can kind of see the evolution that goes on there. But the functional language community kind of couldn't get past their own academic arrogance, to be very blunt about it. They were more interested in arguing about what a monad was and is something inside of the category theory of endofunctors, and who cares? At the end of the day, does it make it easier for me to build a service?
Right.
And so that window was missed. And so we're really overdue for a new window of. And so part of it is thinking about what does that thing look like? Or, as I spend a lot of time doing, cruising a lot of the academic space and, GitHub, very bluntly, looking at new ideas in programming languages. And there are some really interesting ideas. This is actually a session I do at some conferences where I talk about next gen programming languages, right? Like what happens if we start, we talk about object orientation or we talk about procedural or functional. Those are your key metaphors. What happens when we take service as the key metaphor for the language? What happens when services are a first class construct in the programming language? What does the language do? How does it operate differently? Composition becomes a much, much bigger element. And we start working with, core primitive data types like JSON or like CSV or some of those other things.
Mhm.
So that's part of the technical things, right? There's some really interesting stuff. And look, I know everybody is absolutely over the moon over AI right now, all this
Sure.
generative AI stuff. The
Yep.
fact of the matter is the generation of code has never been the hard part in software. The hard part has always been the ability to manage all of that
Mhm.
code. And generative AI doesn't help
Yeah.
us at all with any of that. If anything, it exacerbates the problem. It's very reminiscent. And this is where 30 years of history becomes really useful. About 10 or 15 years ago, we were really, really excited about case tools and the ability to generate code out of those case tools. Do you remember
Yep.
UML?
I took a course in the late 90s on case tools, and I have never used a single one of them.
And UML, right? And UML is
I've used a simplified UML. I do use simplified
everybody
UML.
has. Everybody has, right? But IBM, for example, and Rational Rose, they took it the next level and they said, hey, if you could draw it out pictographically, and everybody does this about every 10 years or so, everybody gets this wild hair idea that if I can draw it, we can program with it,
Yeah.
right? Even going so far back as to the early 90s, there was a programming language called Prograph for the Mac, which was literally a flowchart-based programming language. And the generation of code has never been the problem. The problem has been when you come back around and are trying to figure out how to put new stuff into the code. And particularly all of these generative AI models, by definition, they introduce non-determinism.
Mm-hmm.
And so as programmers, how many people really want to work with a compiler that won't generate the same code given the
Every time.
same input,
Yeah.
right? We
Yeah.
really need deterministic behavior. We really
Mhm.
need. And so we're using the generative AI to try to catapult us past this barrier that we've built for ourselves because we can't get past the Java and the C#, right? And so we say, oh, we'll let AI generate a ton of code. We'll use frameworks to help abstract away parts of this, but you still end up, for any non-trivial service scenario, you still end up having to build a ton of code, right? Just like back in the days of C++, when we didn't have garbage collectors, you had to build a ton of code in order to be able to manage your news, your deletes, et cetera, et cetera.
Yeah.
And so we are absolutely ripe for something to come around and say, here is a way to think about the problem that is well abstracted, that doesn't hide a lot of the things. We still need to drop down a level periodically, in the same way that Java occasionally needs to drop to native code, C# has pinvoke. We still need to be able to trapdoor our way down, but the other 95% of the time, we just want to think about things at that higher level of abstraction. And so from a technical perspective, that is a really interesting and compelling problem, right? But part of the other thing I do, as I've gotten more senior and I've taken some roles that were, purely management, right? There's a whole slew of problems that occur at a managerial level that, that require their own approaches and solutions, especially because if you're somebody who really likes problems, one of the great problems about software is that pretty much all the problems are people problems. And people are intrinsically non-deterministic, which takes us back to our, developers really like deterministic solutions.
Right.
Which is part of the reason why so many developers go into management and then back away from it as fast as they can, because they discover that I can't just have the same conversation with two different people and expect to get the exact same result, right? Me personally, my educational upbringing, my degree in college was all about this non-deterministic squishy stuff, right? I was an international relations major. You really want to talk about things that don't follow rules. Let's talk about nations and the choices that they make on the world stage.
Sure.
And so for me, I'm personally very comfortable with, questions that don't always have the same answers, which means it makes it easy in some respects to sort of look beyond what we've currently got and kind of say, okay, yeah, C# is a great language, but we really should be thinking about how we want to elevate what we do. And that's part of the reason why I really liked F# for that reason. It was a nice object functional synthesis. I really thought that would be sort of the, picking up the torch where C# dropped it off.
Yeah.
But Microsoft made the very specific decision to promote C# over F#. And as a result, they sort of took a bunch of features out of F# and shoved them into C# to the point where now, has anybody ever actually tried to write a C# language specification? Microsoft gave up like 10 years ago, right? They write specs for individual language features, but at what point does that language collapse? Because that was one of the principal criticisms of C++. The language was too complicated. I think it is very fair to toss that same criticism at C# right now.
Oh, sure.
And if so, if you're a vice president at a non-technology company, how do you build stuff? How do you build your teams? How do you look to hiring for the future in ways that future-proof you, or at least future support you? You can't really predict the future, but at the very least, how do I think about, some of these things coming around? Not just which language is going to take over the world, but how do I hire people? How do I train them? What sort of expectations do I hold out for them, in terms of performance reviews and whatnot? All of these are really interesting puzzles, right? And, you talk about getting motivated. These just thinking about all these ideas, thinking about the ways in which we try to solve them, thinking about the ramifications of, I'll be doing this stuff till I'm 90 because it's just really interesting.
Yeah. Right. And you are a true software architect, and you think that way. I've toured the Empire State Building twice, and I've taken some people, and they have a whole museum floor on how that was created. And they talk about the actually two architects that built the Empire State Building, and it was designing what the building should be, choosing what types of materials and the floor plans, and then it was also the process for actually getting it built and having the steel ahead of the different layers, and holistically, so that the end result was it was built in a year, it was on time, and nobody died in the process.
Mhm.
It wasn't just, let me draw the shape of a building and let me say it's going to be this, and then somebody else has to figure out the process. It's like holistic, and there's some areas of architecture that are just a little bit myopic instead of all encompassing, holistic.
A little bit. I mean,
Right.
one of the things, very, very honestly, Jeff, one of the things that frustrates me a great deal about software architects, the individuals who call themselves architects, is so frequently we fetishize complexity, right? The more boxes, the more arrows, the more cylinders, the more complicated the diagram looks. We look upon the blueprints for the Empire State Building and we salivate. We get so excited by all of those lines because, quite frankly, I genuinely believe it's kind of a self-defense mechanism. Because if the production of the artifact, if the production of the diagram, if it were simple, if it were box, arrow, cylinder, and that's all it was, people would look at that and say, what do I need you for? I can draw those 3 things, or 5 things if you count the arrows. How hard is this? But as anybody who has ever tried will tell you, creating something simple is actually so much harder than creating something complicated, right? I forget who it was, but there was some artist who, people would routinely come up to him, "Oh my God, this is amazing. You're so amazing." And he would say, art, what I do is actually very easy. You want to talk about something that's really hard, draw freehand a perfect circle. Don't use a protractor. Take your hand and draw a perfect circle. He said, I've been painting or I've been drawing for 50 some odd years and I still can't do it. Right. But the perfect circle actually has a really, really high degree of power to it. Right. And the fact that, for example, it can roll, right, and it can lose minimal amounts of friction. And there's a lot of things that we use just out of the simple wheel, built out of the simple circle. Right. Gears are an outgrowth of the circle, et cetera.
Yeah.
Building simple architectures, ones that will actually stand up over time, because if it's simple, it tends to be much more resilient, right? There's a reason why when you look at a bridge over a large gorge, there is a circle underneath it, because that turns out to be one of the best ways to support that, right?
Yeah.
And it's just an arc, right? But that is the best way to distribute all of that pressure and load and so forth. Building something simple is so much harder than building something complex, particularly because, again, kind of like with the writing of code, creating the diagram is only the first part of this, right? Really, the strength and the success of an architecture comes as we operate it, right? When something goes wrong, how do we tell that it's wrong? How do we know that our system is failing somewhere? Right? What signals do we give off? People are like, oh, yeah, we've got metrics, we've got OTel. Okay, but where is that data going? And are you essentially requiring your system administrators to sit there and stare at logs all day long in order to spot the problem before it becomes a problem? Because if that's your expectation, I can guarantee you right now, nobody's going to do that. And so all of the metrics, all of the logging that you put there is absolutely going straight into the bit bucket until the problem has already occurred and you want to go back and do a postmortem and say, oh, see, this was in the logs. You should have spotted it. You're not helping, man. You're not helping. How do we bring these concerns to somebody's attention? Because every software system on the planet at a certain point has to put its hand up and say, help, help. I need an adult. I need a human being to come in and fix something.
Right.
How do we structure this? How do we create these alerts? And that's just one teeny little bit of the whole resiliency part of the problem. Most architects, they get really excited about drawing all the boxes and arrows and so forth, but they don't think about it temporally over time, including, for example, how do we transition from where we are now to where we want to be over time, right? How do I move the full speed running train from this set of tracks to this set of tracks without the passengers noticing, right? These are hard problems that many architects, and when they create their really, really complex diagrams, then you say, okay, and how are we going to transition? That's when they go, oh, no, 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 no. That's an operations issue. I just built you your end state. I don't know. You don't get to just, wave off on that.
You mentioned a couple of things specifically on logs and used a term alert, and the sophisticated people in life site operations have figured out a couple of these primitives called alert and alarm, where it's like, okay, alert is somebody needs to figure out if there's something there, and then alarm is get everybody because something is really wrong and it needs to be fixed immediately. And those concepts are different, and we need to do things. But then we have to map which signal is an indicator that one of those has happened, or which signal is an indicator that one might be starting to possibly happen.
Yeah, because that's part of the thing too. Is at what point does an alert become an alarm? At what point does a signal become an alert? Right. And again, as developers, we frequently like to think of things in binary terms. It either is or it isn't. It's either an alert or it's an alarm or it's a signal. And we want to have these really crisp definitions for when one goes to the other. The problem with doing that in many cases is that, well, depending upon what's going on with the signal, it might move over into alert territory and then move back. Move over into alert territory and then move back because it's fluctuating back and forth between two values.
Mm-hmm.
And in fact, if it continues to fluctuate like this forever, that is its own level of problem, right? The fact that it keeps bouncing back and forth is the issue. This is an area, ironically, which a lot of the AI folks back in the 90s were flirting with, the idea that maybe things aren't quite as binary as we think. And this is the whole space of fuzzy logic. Right. And so this is a space where, if you're familiar with some of the old AI stuff from 30 years ago, you say, or 20 years ago, you say, I wonder if we can apply some fuzzy logic and sort of create sort of these overlapping scenarios where if you've wandered into this space, but you stay there for a certain while, we categorize that differently, right? As opposed to saying it's just a signal or it's just an alert or it's just an alarm. Right. In some cases, the actual issue is how quickly does it move, right? Because if something goes from basically a zero signal to all of a sudden we're in alert territory in one cycle, okay, that's a really big problem. Even if it just remains flat from there on, what in the heck happened right here? Because now that means that if it can jump that far that fast, we desperately need to know why, because when it jumps again, it's going to go straight into alarm territory and possibly crash territory if it does it in like a single cycle. Right. So there's all these different issues. And quite honestly, thinking about all of this, reasoning about all of this is part of the reason why I am an amateur philosopher, right? I very much consider myself a philosopher. And the fact that I don't get
that's
paid...
only because there's no professional philosophers by its very nature, right?
Well, so you could argue that there are people who are paid to be philosophers, but they're generally not running around with the title of philosopher, right? And part of the thing is nobody likes philosophers. They really don't, because we have this really annoying tendency to ask questions to which there are no easy answers.
That's
right?
Just wisdom.
Well, wisdom comes from bad experiences, and so we hopefully will learn stuff out of that. But in many cases, it's not wisdom because we don't know the answer, right? We ask the question because it's interesting, like what's the next gen, what's the next phase in programming language? I don't pretend to have the answer. I just know it's an important question that needs to be asked, so that other people can start thinking about what that looks like. Or more importantly, you can be aware of that question and then start doing your own research and discover that there are actually a couple of service-oriented programming languages out there, and start playing with them and go, holy crap, this is so much easier to build a service than doing that ASP.NET or all of that Java stuff, right? This is actually Hello World in like this much code, right? 5 lines of code to do a Hello World service, and it's got all of the other stuff that I want.
Mhm.
Philosophy forces people to ask questions, and in some cases, we value the questions more than we do the answers. And that's exactly the mindset that we really want to have, particularly if you're an architect, is you really need to be thinking about, okay, if we go do this, what are the likely ramifications of, right? If I build this really, really complex architectural system, well, what happens if this piece gets ripped out for whatever reason? What does the rest of the system do? And
Mhm.
most of the time, particularly with all these HTTP based APIs, request blocking response kinds of approach, take one piece out, the whole system comes to a crash and halt because we block indefinitely waiting for that one
Yeah,
piece to come
right.
back,
We
right?
assume it'll never go down and never be slow.
Yes. And this is where we get into fallacies of distributed systems and fallacies of enterprise systems and yada, yada, yada. But this is where, as a philosopher, right? That's why I really think philosophy should be at the heart of pretty much everything we do in the software space, right? Forcing yourself to ask all these questions, technological as well as product, as well as business, right? Is what we're building actually going to be of use to the business? A lot of people just kind of take it as a given, but particularly as you start getting into the higher levels of your career, you really need to start asking that question more and more often. And when it looks like you're about to build something that won't actually deliver any particular value to anybody, it's kind of a necessity. It's almost a professional responsibility to say, okay, wait, has anybody checked in with the product folks? Is this actually what they want?
Mhm.
Or did they want something that we've transformed into this thing because we desperately wanted to put some AI in the center of it, right? Because that's what everybody is doing. So, yeah, it's. I have completely lost the thread of what question you asked, but that's also
Well,
another philosopher trait. Take your question and turn it into my question, and then we go
there it
from
is. So you mentioned that we're ripe or maybe on the cusp of, a next gen programming language. And of course you're right, but the question is what year, but we won't talk about that because we don't really know. So,
get out your betting pads now, folks. Here's what the pool looked like.
right. Is it this decade? Is it the next century? But, um, the code that we have now,
Mhm.
C sharp, even if next release of Copilot or JetBrains AI assistant or Codex or any of the tools are able to like perfectly like construct the C sharp that you wanted to, let's say that happens very quickly, that happens this year, that still doesn't change the fact that C sharp is what's going into the Git repository, and C sharp is getting what's built. And when we have to change something in the software, we start with the C sharp that we have, and then we make a change. And when something's not working in production, there's a bug, we have to change some C sharp or HTML like JavaScript or
Yeah.
whatnot. So right now, the fact that the software is C sharp and the .NET libraries and all that, um, the AI driven development, that's just tooling. That's just like my latest book. I got tired of typing. I'm actually a pretty good typist, but I fell out of love with typing, and I ended up using Windows H, and I ended up like dictating with my mouth just full on sentences and paragraphs, and I let the computer actually type it into Microsoft Word, and I loved it because stream of thought, and it's like, okay, let's get this mechanics of my fingers and the typing just out of the mix, and let me just formulate this book kind of from my head. And we're already there, aren't we, with as far as the construction? If I wanted to if I go and literally say, give me a customer class with properties, ID, string, first name. I mean, I could literally from my brain speak into the microphone, and Copilot would lay out the C sharp. I could literally dictate it from my head right now, um,
But
and it gets it pretty good.
the thing of it is, Jeff, right? A the I don't know if you've ever looked at the transcript, right, of something. And I encourage. I don't know if you do a transcription service for
I do
the
every
podcast.
podcast. I have transcriptions, and yeah, there's some errors, of course.
Well, it's not just the errors. I want you to read the transcript, but then
Okay.
I also want you to read aloud the transcript, because what you will find is that the English language that we use, and I believe this to be true for all human languages, but I only speak English fluently, so I can't say for certain. I believe that spoken English is very different from written English. That's why, for example, when you were reading my bio,
Yep.
it was painful, wasn't it? It was painful. Just admit it. Just admit it, because
No, I don't think so. Maybe for you.
well, but I mean, listen to the sentence construction, right? And listen to how the various things were paused. And I'm pretty sure you took a couple of shortcuts in a couple of places in terms of reading it, because it doesn't read aloud well. You can scan it with your eyes very quickly, but your ears, we have very different levels of fidelity in terms of being able to, communicate the bandwidth of information and so forth. And so I've known a number of people, because Dragon Age has been around since like 10, 15, 20 years, right?
Yeah, the
Being able to do
text tool.
yeah. Being able to do speech to text has actually been a solved problem for a long, long time, right? What we didn't have was the ability to do natural language parsing. I mean, we could do NLP. We've been able to do NLP since the 60s.
Without punctuation.
Well, and the NLP systems are much, much better now at understanding, at least being able to pick out parts of speech and being able to grab some level of inference. They still don't have an underlying reasoning model to understand these various things. That's why you can walk up to ChatGPT and say, how many R's are in strawberry? And they will tell you 2. Because they have seen so many queries that say how many R's are in blueberry, how many R's are in blackberry, how many R's are in strawberry, and they just sort of follow the pattern. They're not actually counting the letters. They're just looking at the proportion of responses to this, but they're able to pick out that this is a question, that this is in fact asking about the number of letters. They're able to do at least a very surface level, parse of this, but they have no reasoning model underneath it. When we start talking about, you started talking about dictating your code, we could easily build a voice interface for code in the same way that we could easily dictate a book. But what I discovered from just this conversation is you and I write books very, very differently, because I don't sit down and talk it out. I frequently have to go back, right? I'm constantly editing as I'm going. And that's very difficult to do in a spoken scenario, because speech is very much a left to right, unidirectional, serial kind of fashion. When I'm writing, I will frequently be writing and realize, oh, I actually want to make a reference to something that I haven't introduced in an earlier paragraph. So I'll stop there, jump back, introduce that idea, then come back here and keep going. Oh, wait, actually, this would make more sense if I introduced this like a paragraph earlier. I'm constantly revising my flow to be able to make what I'm doing make sense. I couldn't dictate a book. I absolutely could not. And so I think spoken English, first of all, is a terrible format for a programming language, because there is so much inference, there's so much context that flows between two people engaging in a conversation that a machine will just never be able to pick up. But the other thing is, the English language is notoriously imprecise. And so all this notion of spoken language being the source code of the future, people have been chasing that for years. And there is, in fact, a programming language out there that reads very, very much like spoken language. We could get there.
You mean COBOL?
No, I mean Inform. No,
Okay.
not COBOL. COBOL. Jeff, come on. Quit swinging for the easy pitches. No, there's a program language called Inform 7. It's a interactive storytelling language, right? So basically, if you ever wanted to create like your own style of Zork style fiction, Inform 7 will let you create that interactive fiction, and it's very human in its source code. It's still a programming language. The parser is written to be able to understand all these different forms of being able to say there is a hat, and taking the hat, putting it in the box, means the character no longer has the hat. All of this is essentially source code to the interactive fiction engine. So if we really wanted an English-like programming language, we could have it. We could follow the example that was set by Inform. The thing of it is, people have been experimenting with that kind of precision for programming languages for many, many years. And what we have found is that it actually doesn't work because it kind of doesn't address the needs of the various users, because we have two very different styles of users. We have the casual developer who really, really likes that. But as they start typing this stuff out, it starts getting a little verbose, and they start looking for ways to shorten it up. They look for shortcuts, which takes us over to the professional. As you write more code, the more professional you become, you really start looking for terse ways to express this, right? But we could easily do a, English C# where we say, I want a class, call it customer, right? But eventually you start looking for ways to shortcut that. So you say class customer.
Yep.
Right? Begin. Well, okay, instead of the keyword begin, because go back 30 years ago, 40 years ago, programming languages used begin and end. And then we shortened them down to single characters because that's faster.
SQL still does. Begin and end.
Yep.
Begin transaction, end.
Yep. And remember that SQL was created originally as language to be put in the hands of end users so that they could query the database directly to get the data they wanted for reports and stuff, right? People sometimes lose sight of the fact that SQL was never designed for programmers. It was designed for end users, report writers, and so forth. All of this basically comes back to what the generative AI stuff is doing is it's parsing all of this pool of stuff. Whenever you train a model, right, you're basically giving it a ton of stuff, supervised learning, etc. And then it is responding based on what it was trained on. So first of all, it's never going to be able to come up with anything that wasn't in the pool of what it was trained on. So by definition, generative AI is not innovative. It is simply duplicative. And so if what you want to build is yet another web app with yet another form that goes into yet another database, it's got you covered, boo. It's so easy. But when we start trying to do new things, when we start trying to push beyond that or outside of that, or think about how we, disrupt the paradigm, AI is not going to be able to help as much with that. And what you're going to find is that, at least what I'm finding, what a lot of the people that I know in the industry are finding, is that I don't want to step up and just say, hey, AI, build me an app, right? We don't want to do the vibe coding thing, because people who've been creating these vibe coded things generally find that it's not sustainable. When they go back and they want to add new features after the fact, it all just collapses under its own weight.
You need to be happy with the code that you put in your Git repository.
But as a tool to supplement what a developer does, right? The way I think about some of this generative AI stuff is I think of it as very similar to the pocket calculator or the graphing calculator. Remember in school, you sat down and you were doing addition, and you and I are both of roughly the same
solar
age.
Powered calculator, baby.
And you remember when it was first grade or second grade and you could sit down and do your homework, 1 + 1 = 2 + 4 =, and we had to go through. Calculators can do all of that. Why the hell did we have to study it? Because we needed to learn the fundamentals, right?
Right.
Nobody in school was expecting us, the goal here wasn't to just get the right answers to all these numeric problems. The goal was to teach us the fundamentals of maths so that we could go on and use it and know when to use it in various applications later. This is part of the thing that companies that are trying to use AI to replace their junior developers are going to discover in painful fashion after a while. Yes, you get a short-term hit of getting AI to write all of this stuff, but now as time goes on, finding people who can exceed the boundaries of what AI cannot do, that's going to require people who understand all of those fundamentals, who did the 1 + 1 = 2, and know how to use the calculator to accomplish bigger things.
Well, let me ask specifically. You said these companies are getting a short-term bump, who's actually getting a short-term bump? It seems like an executive budget wish at this point versus saying, "Hey, you have programmers. Okay, let's make sure that they're using the best tools, and hey, we got some new tools coming out. How best do we use them so that our programmers are doing the best they can?" Who's actually right now that you know of replacing a real person with the automation and actually having that give them even a short-term gain?
So,
Is that working? I don't see that working.
well, there are many big companies that are, they are getting some level of success. And unfortunately, I don't have, citations and statistics to be able to throw at you at the moment. And so I could very well be mistaken about this, right?
They're
But
talking about it.
well,
They
they're
want
talking
to.
about it, and I have had some conversations with people anecdotally who have said, "Oh yeah, so I was talking with one VP of architecture who was actually talking about using, for example, ChatGPT to create first pass at creating some pros documentation, right?
Sure.
So imagine I want to create this system, and so boom, I get a bump out of that because now I don't have to write this. ChatGPT has analyzed some of my notes and whatnot and is able to build out. And I go through and make these edits. Not me personally, but the guy I was talking to, he goes through and makes those edits, etc. Those are some of the short-term bumps, right? If I walk up to Copilot or ChatGPT or Claude or whatnot, and I say, "Build me a to-do web app," code comes up, right?
Well,
And
that's
so,
individual productivity. That's just like a lawyer saying, "Oh, you know what? I was able to jam out this contract so much faster," which is a different thing from saying, "Oh, we as a law firm, oh yeah, we've laid off half of our lawyers because we don't need as many lawyers."
well, okay, be careful what you measure here because there are law firms who have laid off half their lawyers and asked the AI tools because the thinking there is, well, if I get individual productivity boosts out of my staff, that means that if I want to keep the same level of total productivity, if half my staff turns into 2x lawyers, then I can fire the other half and I'm still at the same level of productivity I was before, which is the first fallacy because most of the time businesses don't want to stay at the same level of productivity. They want to improve their productivity. So laying off people, even though they've got these tools, blah, blah, blah. I think a lot of companies are laying people off in anticipation of that huge productivity boost being sustainable over time. But the other thing that I think we're discovering is that that productivity boost isn't sustainable. Period. Right? That I can get it to write stuff, but now we are starting to see any number of cases where those legal briefs that AI wrote for you turned out it is citing case law that doesn't actually
Oh,
exist.
yeah,
Whoops.
everybody's heard of the false legal briefs being filed in a courtroom, and yeah, that's bad.
Yeah. And the false medical diagnoses being performed and in the medical space, there's a little bit more rigmarole and rigor required around, diagnosis. And so doctors are more careful. But, there are some doctors who have reported, yeah, I submitted this test result and it came back and said cancer. And then I took a look and it's like, no, there's absolutely no cancer there whatsoever.
Yeah,
There is
yeah,
the one case where somebody submitted their symptoms to ChatGPT. It came back saying cancer, and then it turned out to be cancer, right? But that's one case compared to
yeah.
all of the false hits, right? And again, this is where philosophy comes into play. It's like just because there was one hit doesn't mean that everything else is a success. But I mean, this is part of the thing is how do we measure all of this? How do we see what those gains are? How do we take advantage of this? I think a lot of big tech companies, we've seen all the layoffs from Microsoft and Google and Amazon.
But big
I think,
companies are laying people off for any excuse. They just do that,
well, and I
right?
think I think a lot of them are going through reorgs, but not calling them reorgs because reorgs tend to introduce some jitteriness into the market. People are like, "Oh, so you don't know what you're doing?" Yeah, I think I'm going to sell
Yeah.
my Microsoft stock. Thank you. But if we say that we're laying a bunch of people off and we just kind of, when somebody says, "Is this because of
We're
AI?"
optimizing.
Well, and when the tech press says, "Is this because of AI?" and Microsoft just goes,
Could be. Well,
They're not
okay.
saying anything.
I'll pay more attention when the mid to small companies that originally just only run a software shop of 10 developers or 20 developers, when they say, oh yeah, we're reducing our staff and this is why, and we're getting as much done. But when you take someone with thousands upon thousands of programmers and you say they laid off, it's like, okay, but they're constantly doing that. They can cite whatever reason they want, but they're constantly adjusting.
Right. And the long tail, right? The small to medium businesses, quite frankly, they're never going to lay people off because generally they're understaffed anyway.
Yeah.
Right. They have, one of the great truisms of our industry is the demand for software is infinite, but the supply is finite.
Yeah.
Which does really bizarre things with the supply and demand curves if you're an economics major, which is part of the reason why senior software developers, why CTOs and so forth get such ridiculously out of sync salaries, which is why we see the introduction of all of these tools, because they're trying to adjust for the fact that the demand is essentially, it's essentially vertical. Right. We have an infinite amount of demand for it. We need it. We need more of it. Give us more, give us more, give us more, regardless of the price.
So you started off by talking about, hey, maybe we'll have a different language, but it seems to me, just depends on when it's going to happen, that we're going to get to the point where the actual laying out of the code gets so fast as to be a less significant part of the whole process time. And when you think about the software development lifecycle, and we can argue about that, but let's say if the coding aspect becomes so automated that the coding the coding time shrinks to near zero in the software development lifecycle, you've still got all the other stages of figuring out what you want to build, figuring out how you're going to design, and then on the back end, you got to validate different validation, then get it in front of the hands of the users.
See, here's the thing, Jeff.
Right?
Here's the thing. You're thinking about coding specifically. I'm thinking about writing this out in C#.
Yep.
Right? I'm telling you that's the wrong way to think about it. Let me ask you, how much assembly code have you written recently?
0.
And do you know why?
Because it's all embedded underneath everything else.
Because we leveled up abstractions.
Yep.
Right? We went from toggle switches on the front panel to an assembly language to a procedural language that was basically a higher level assembly, aka C, to a object-oriented language, to a virtual machine, the assembly is still there. If you were to have to sit down and write out your ASP.NET app, but to do it entirely in ARM64 opcodes, right, the coding would be way, way out of scope for what benefit you're getting out of this. The amount of time we spend coding is always going to remain roughly constant. The thing is, what we code in and the level of things underneath that happen as a result of that single line of stuff grows. So I think it was the Association of Computing Machinery did a really interesting study years and years and years ago, where they measured the number of assembly instructions you get per line of programming language source code.
Mm-hmm.
Right? Now, C and C++, C, it was basically 1. Right? It's very much a 1-to-1 mapping. C++, generally it's like a 1.1, 1.2, except in a couple of places, like when you do, when I invoke a virtual method, okay, there's a bunch of preamble that goes on, so I get a little bit higher spike there. Java and C# turn out to be roughly about the same place in terms of number of assembly instructions we get per line of source code, right? Where it really starts to take off is when you start getting into the highly abstracted languages like Lisp, right? Where a Lisp programmer doesn't actually write a program. They write a program that writes a program. What's that?
I say yes, but I've never written Lisp. I've seen
it. That's part of the thing is the way Lisp, the fact that Lisp basically says code is data is code, right? This very strongly meta object facility inside of it, right? Reflection is actually something that was originally pioneered in the Lisp space. And so I take the code and I can visibly modify the code. If you ever played around with any of the aspect-oriented stuff, that was actually an outgrowth of meta-object programming, which was pioneered inside of the Lisp space, right? So there, a single line of Lisp code actually writes a ton of Lisp code, which writes a ton of Lisp code, which then turns into a whole bunch of assembly instructions. So now you start getting a huge surge in productivity.
Mm-hmm.
The C# and Java and C++ developers of the day, they'll say, oh, well, those are just frameworks, and we can build a bunch of frameworks. And so if we're going to count that, all of those frameworks turn into code, which needs to be maintained, et cetera, et cetera. But the larger point is we need to level up the abstractions that we work with to better match, right? To better match what we're thinking about. So if we practically today think in terms of, if I sit down and say, Jeff, I want you to build me a new project, and you immediately say services, we're going to have a service that does this and a service that does that, and that service, then we need to have a language that maps that, because otherwise you have to say, I have services, but now I have to actually rethink this in terms of objects and classes and so forth. We need to think about how we level up the abstraction level, right? Mm-hmm. It's not just about the textual language or the spoken tool that we use. It's not just the tokens we lay out. It's more about the abstractions that we work with and how the language reflects those. That's where the real win is going to come from. And AI doesn't get us there. AI just makes it easier to spew out lots of lines of C# code in the same way that we could use AI to write that hello world service entirely in ARM64 assembly language. It can be done. Right. We just don't want to do it because trying to figure out if it's correct is impossible.
Well, this sounds like the age-old build versus buy and raising the abstraction level. If I was gonna build a house, I could, bring a bunch of raw lumber and have people, cut it in the right dimensions. Or I've seen, modern construction, getting a pallet of materials and all of the boards are already cut to the specified dimensions. And so the entire act of measuring wood and sawing a board to the dimensions that you need is totally removed from the job site. That's just one example of abstracting up. And then like the rafters of the roof, I've seen them come in, and I'm not a construction expert, but they come in pre-assembled rafters where they're these A-frames and you just kind of tack them up. And then the steel buildings and the barn dominiums, like an entire steel kit where it's just like, oh, bolt, assembled, and like, oh, you want to finish out the interior now because the structure is kind of built. I mean, it's all these different levels, this huge continuum of how high can we get the abstraction so that we just get the job done.
Well,
faster, consistent
this is
quality.
where we have to be careful about analogies between us and building construction, right? Because frequently when we see people showing up with those prefabbed components, right? The reason we do that is because we're building the same house over and over and over again throughout that development. And so we know that we need the rafter that has this slope and it has this size and it has these spokes and so forth. The more interesting analogy would be if we had like the giant house assembling robot, right? And you're seeing this now with some of these, those things that will just go around and do the 3D printing
the concrete 3D printing of the structure.
Yeah, but if we imagine a more sophisticated robot to do a traditional house where it's actually picking up the boards and this, banging them together and then putting them down, you imagine this octopus tentacly thing
right.
with just arms everywhere, right? That would be a little bit closer. But more importantly, we start thinking about things, when we start talking about the whole 3D printing thing, that actually forces us to reimagine what constructing a house really means. And it starts opening up some ideas because, for example, the 3D printed house could actually do everything as a geodesic dome, which would be really hard with the wood-based materials and the prefab things and so forth. And there are certain places where it would actually make sense to have a geodesic dome, particularly one made of concrete, with very little in the way of windows. I'm thinking specifically about, the middle of the Arizona desert to keep it cool and yada, yada, yada.
Yeah. Right.
And so we have to be careful about drawing our analogies, because a lot of people have been talking about those prefabricated components as, well, first they were libraries, right? We're going to build everything in libraries, and then you just use the library. That's your components showing up. And then it was frameworks. Well, now we're going to have these frameworks that you just hang stuff off of. And then it was, well, we don't actually like frameworks because they're too opinionated. Let's go to toolkits where you can pick these things up and assemble them yourself. And then we said, no, that's too much work. Let's actually go back to opinionated frameworks. And we bounced back and forth around all of this. And every single time, everybody uses that analogy of
But also
pre-constructed.
services.
What's that?
Also services. Like, why would I do my own payments? Let me use PayPal, Venmo, Square, whatever it is.
Software as a service. Yep. All of that stuff, right? Everybody loves to go to that construction metaphor as a way to say, see, this is going to be so much better. And yes, it will be better, particularly because it's all this stuff that I don't do, I don't use. I just use, I don't build, right? That takes you back to your build versus buy metaphor. Again, when we start thinking about elevating the abstraction levels, this is where we really start thinking about bespoke stuff. Because if all you want to do is build a Yelp clone, there's all kinds of ways to do that, right? Using all those prefab components. Is that really going to get you the significant business advantage? This is why you have to be thinking it back to the other way. I just want to build a Yelp clone for pets. Yes, we're going to do a Yelp clone for pets because Yelp was successful. The startup scene is filled with these, right?
Yeah.
That's not actual innovation. That's just trying to take an idea and jam it together with something else. Yeah, we could build a Yelp style architecture. There's a lot of tools that know how to build that already. It's when we want to start doing things differently and building things that aren't the same thing, Me Too style architecture or system that everybody else had built before us. That's where companies frequently want to be. They want that innovation, but in many respects, particularly in the fintech space, they want the innovation, but they don't want to actually innovate, which is kind of weird. Right. Well, yeah, but we're going to standardize on these well-established tools. This is really where I really expected the whole DSL movement to have more traction to it, and the idea to build, your own stuff, your own tools. My father recently just forwarded over an article he saw in The Economist about Jane Street Capital. I don't know if you're familiar with them, but they're
not deeply. I've heard of them.
Yeah. Well, they're a company out on the East Coast. They do a lot of currency arbitrage, and every single one of their things is built using the programming language OCaml, which is, It's
been around a while.
It's been around a long while. It was actually a strong part of the inspiration for F#. The syntaxes are almost identical. And economists positioned this as this was a brilliant business move to ensure retention of their programmers, because Jane Street hires literally every OCaml graduate in the world.
Oh.
They've even gotten to the point where they've created their own flavor of OCaml called OxCaml, sort of a tip of the hat back to Oxford, I think, where a lot of the OCaml work was originally being done. Okay, was that a decision that was deliberately designed to create a business advantage for them, or was that just a happy outcome because they found a language that worked for them? But I genuinely believe that companies really should take that as an object lesson and think about, how do we gain a competitive advantage by choosing something that's not middle of the mainstream? Sometimes that means you build your own DSL. And that's where I really thought a lot of the value of the DSL was going to come into play. But most companies found that they didn't really want to go that far. They wanted innovation, but they didn't really want to innovate, which is why the DSL thing kind of fell apart. And I think that's large part of the reason why a lot of companies are very hesitant to explore anything other than the stuff that's firmly in the mainstream. And as a result, we continue to labor using these mainstream languages and tools.
Well, like you said before, and as we kind of last thoughts before we close up, there's more demand than supply. And given that, there's going to be engineers who move from company to company, and then you got to hire people in. And the more rare your software is, the smaller the labor pool to replace them.
There is that argument, But at the same time, I would argue that the amount of time it takes me to parse and understand all of the various things that make up your stack, right? So let's talk about C Sharp, for example. Let's talk about a
Mhm.
traditional .NET stack. You've got C Sharp, you've got Entity Framework, you've got SQL Server, you've got, which means you need to know SQL. You've got your
Mhm.
chosen web framework, be it React or Angular or what have you. You got all of these things here, right? Plus, then we've got the frameworks that sit on top of that, right? The ASP.NET framework. We've got, maybe you're using Microsoft Orleans, which is that actor framework. Maybe you're using Aspire, which is that other actor framework. There's a ton of stuff that you have to know in order to be able to come at this, right? That doesn't even begin to approach all of the company specific frameworks that people layer on top of, which there is no precedent for. You have to go learn all of that stuff once you get there. The amount of time it takes you to actually be a productive member of that team is measured in months, shall we say, right? You can understand the code, you just don't understand the ramifications. You're going to make a ton of mistakes, usually 3 to 6 months before you're a productive member of that team. Jeffrey Palermo, if I put a language in front of you that you had never seen before, but which actually abstracts away pretty much all of this, do you think you could learn it in 3 to 6 months?
Well, I'm sure I could.
There we go. The act of learning the new thing, if we already assume that a developer is going to have a 3 to 6 month time before they will be productive, right? I don't mean they'll be able to accomplish little things. I mean actual productivity. I give you a thing, you go off, you do it, etc. I genuinely believe that you can actually get better productivity out of a DSL-based approach that is tuned to the particular problem at hand, particularly because the other thing it does is it actually opens up your pool of people who can contribute. Because if we now create a DSL that allows, let's not say casual users, although that's another interesting option, giving it to your users to be able to start working with and play around with. Let's say product people now have a tool by which they can start to realize some of their ideas directly. Now, all of a sudden, we start getting some really interesting boosts in terms of productivity because they can playground some of their ideas long before they bring it to the technical folks to say, I want you to build me one of these. And we take that and perhaps spin it slightly so that it becomes more scalable, more usable, whatever. I will posit it this way. There were a lot of applications in the world that are running today that started as an Access or a FoxPro app. What is the Access or FoxPro tool for the non-technical but technically minded product person to use inside of the company today?
Mm.
If the company doesn't have one of those, then you're already in a terrible bind where a product idea has an idea. They have to try to sell the technology folks on the idea. The technology folks have to try to do a prototype against all of the other demands for their time, because again, demand is infinite. If we can put some of these tools in the hands of the product folks so that they can at least realize their idea and play around with it, we actually open up more productivity for the developers and we get better innovation in the hands of the product folks. But it requires you to take a step back and think about what is our domain? How do we want to think about our domain? How do we want to create the abstractions over those domains? It's almost a domain-driven design, but instead of taking it directly into objects, we start taking it into a new space where we start thinking about how do we reason about this problem, and let's build a syntax that actually maps that reasoning. That's the hard link right there, right now.
Mm. Philosophy indeed, my friend.
This is why
Lots of good
people
stuff.
hate philosophers.
Lots of good stuff to think about. Lots of good stuff. Man, it was so good having you back on the show. Great
That's always
conversation.
it's always fun to chat with you, Jeff. It really is.
Yeah. Thanks for coming back and visiting with us. I appreciate it.
Always fun, always interesting, and going back to your first question, this is why I'm still here, right? Because this is, thinking about all this stuff, talking about all this stuff, man, I mean, we could do this all day long. I mean, you and I have had dinner together. I could just go for hours and you wouldn't even have to say a word.
So, speaking of that, we'll include links to the show notes, but listeners can come and see you speak live
Yeah.
A- And let's see, VS Live is the next thing coming up before KCDC. Those the two?
Yeah. VS Live in Redmond, so on the Microsoft campus. And there will, as one would expect, there will be a number of Microsoft-y type folks who will be doing presentations on all of their stuff. And that I believe is in August. KCDC, I believe, is in September, late August.
August 13th is what I
August
see.
13th. Oh, that's right. It's the week after.
Kansas City, Missouri.
Yep. And actually there, if I'm not mistaken, I will be doing a session. It's either the session on new programming languages. I know I'm doing that a couple times this year. Or it's actually a session I'm doing on writing, like literally prose writing. Why this is actually a very, very useful skill for developers to know and how to improve it. Beyond just being able to effectively communicate with your peers, a lot of times from a psychology perspective, we think we know how we want to do something, but until we actually get it out of our head and into some form of external, we've often thought about using diagrams and so forth to do this, but writing as a whole really helps us structure our thoughts. And sorry, Jeff, I don't mean just dictating into Dragon Age. I mean sitting down and laying the things out, building your outline, et cetera, et cetera. Yep. It's a very useful tool to understand your own thinking. And quite frankly, the value of writing is that writing stands alone. Bezos banned PowerPoint from meetings at Amazon for a reason, because a really strong presenter can make a really bad idea look good, right? Writing actually takes the presenter out of the equation, and so it makes the ideas kind of stand on their own a little bit more. So I'll be doing a session on how to write.
Nice.
Yeah.
And we'll also include a link to your website, newardassociates.com, because like the entire calendar of speaking is on there. So
I try to keep that up. Yep. And the blog is hanging off of there too, blogs.newardassociates.com, which is where a lot of my philosophizing goes these days.
Brilliant. All right. Well, thank you so much. And dear listener, until next time, keep shipping.
You've been listening to the Azure and DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and anywhere you get your podcasts. Visit our sponsor, ClearMeasure, at www.clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.